JavaScript's ecosystem is fragmented at every layer. If you look at the innovation, the differentiation part that actually matters, it's the frameworks. It's how you design APIs that allow people to build things fast. The reason all these frameworks started to converge around Vite is because they realized it's now less and less meaningful to be spending their time building sort of unusual or novel solutions at the build tool layer. It's more meaningful to innovate at the API layer.
Hi there, and welcome to PodRocket, a web development podcast brought to you by LogRocket. My name is Paul, and joined with us today is Evan Yu. Evan is the creator of VoidZero, Vue, and Vite. In this episode, Evan and I are going to dig into the fragmentation of the overall JavaScript tooling and how VoidZero aims to unify that toolchain. We're going to talk about the future of JavaScript tooling, including Vite Plus, and potential collaborations, new runtimes, and what's next for the JavaScript ecosystem as a whole. So here's our episode with Evan Yu. Hi there, and welcome to PodRocket. My name is Paul, and joined with us is Evan Yu. We've had Evan on a couple times before, and we're excited to have him back again. And we're here to talk about front-end tooling in particular, something that VoidZero focuses on. And we're going to dig into sort of like the past, present, and future of front-end tooling, particularly through the lens of Vite. Sprinkling in some Vue in there, because why not? So welcome to the podcast, Evan. Excited to have you back. Excited to see what's cooking.
Yeah, glad to be back and excited to share what we're working on.
So last time we had a overview when you were on PodRocket of VoidZero and what it does, just as a reminder of folks, because this is your company. What are you guys poised to solve with the VoidZero?
Yeah, the tagline for the company is unified toolchain for JavaScript. The keyword here is really unified because I guess everyone working with JavaScript who have been in the ecosystem long enough have probably touched dozens of different tools because we need all those tools to solve different things in our workflow. And everyone is used to downloading tons of packages from NPM and have huge packages of some, if you have a production project. And in a way, we've taken it for granted. And also, it is a result of the JavaScript ecosystem being very, very decentralized. The language itself was created without too much thought about what's going to happen afterwards. And somehow it became the only language that you can run in browsers. And so everyone has to use it. And we started running into scaling issues. And all the developers just started solving our own problems. But everyone is doing it separately, their own ways. So we ended with a lot of tooling, which are excellent in their own ways, but they were never designed to work together because they were designed by different people working with different constraints. But I think over time, over the years, we're seeing a lot of the needs or the best practices for certain problems have more or less stabilized and converged on some commonly agreed things. Like for a particular problem domain, you would find some solution become the winner, or most of the people would choose to use that. For example, ESLint has become the de facto standard linter. Webpack was a de facto standard bundler for a period of time. I think we're at a time where we're seeing a lot of mature solutions in each category, but these solutions are also burdened by the past, burdened by two things, actually. First is they're all written in JavaScript itself, which means as the size of the application that we're building continue to grow, JavaScript written tools are starting to show performance bottlenecks, especially in large projects. The second is these tools, they evolve from their separate roots because they evolve from something that was never designed to work together, right? So fundamentally, these tools don't understand one another. ESLint does not understand Webpack. Webpack does not understand Jest. So when we're configuring these things, we're always forced to essentially make sure all of them can have the same understanding of our code base. For example, if you configured an alias, your bundler, your test runner, your linter, everything that deals with your source code needs to know the same alias and know how to follow it and to resolve your modules, right? So this kind of little inconsistencies or gluing plumbing that's needed to make all the things work together, it just compounds with the more tools you have, the more complexity you have in your app. The bigger your app gets, the more this kind of tooling issues you run into. So this comes back to this whole premise of something that's unified, like where we are solving the same set of problems, but we solve them with tools that were designed from the ground up to not only work together, but to be built on the same foundation, to be built on the same parser, the same AST, the same module resolver. And I think that will potentially solve a lot of the issues that we've just accepted as the status quo for JavaScript tooling. But we believe a starting from first principle, and build something from the ground up along the ways we are trying to do could potentially solve that.
Do you think that it's almost a strength of the JavaScript ecosystem? We always talk about, with not just you, Evan, I think anybody that's talking about the ecosystem, it's the
Yeah.
word fragmented is like in a neon sign with lights around it flashing. Hey,
Yeah.
but in some ways, it's almost like a strength of the JavaScript ecosystem. If you want to look at all the different ecosystems out there, goes to Rust, and the JavaScript ecosystem probably is the closest simulation to Darwinism that you could find out there because of the amount of people trying stuff and
Yeah.
then stuff bubbling up to the top. So with that lens of how the good stuff comes out of the cruft, and maybe it's not good, but whatever's
Yeah.
making sense,
I Yeah, I definitely get where you're coming from. So I think the idea here is there are different layers, all the layers of, say, starting at the bottom from the parser to the transformer to the bundler to the build tool, then to how you run tests, right? I think it is actually good in the early days that we start with multiple different solutions at these lower layers. And over time, we arrive at the good or the solution that everyone agreed on. This is actually probably the best way to do it at a certain layer. And I think for an ecosystem, right, like essentially the convergence or the consensus about like the best practices start at the very bottom level, is slowly solidifies over time. Maybe in after 5 years of Node.js, people have agreed on, okay, for example, this is probably the best way to parse JavaScript. Like when Babel came out, everyone was like, okay, let's work around Babel to write transforms, right? So it slowly solidifies over time and the abstraction layer gets higher and higher. It's also like how programming in general, like when operating system first came out, people were like, there are hundreds of different ways of doing how you want to do an operating system. Then there's assembly. Like people originally everyone was writing assembly, but then we have languages built on top of assembly. So we just take for granted that, okay, like these CPU architectures are what we're gonna use, right? These are the operating system that we're gonna use, right? So slowly, layers upon layers, they get, people agree on a few good, agreed on solutions on consensus, right? So we stop arguing about those things at that certain level. People would still argue like Windows or Unix, but most of the other solutions have just faded away, and we agree on a few things that's actually good and solid. Because that's also necessary progress. Because if we can never agree on these lower level things, then it actually stifles higher level innovation. So I think what we want to do for the JavaScript ecosystem is similar, because we see that JavaScript ecosystem is fragmented at every layer, and that is not good. Because if you look at the things, the innovation, the differentiation part that actually matters nowadays, it's the frameworks. It's how you design APIs that allow people to build things fast, right? And these frameworks, the reason all these frameworks somehow started to converge around Vite is because they realized it's now less and less meaningful and valuable to be spending their time building sort of unusual or novel solutions at the build tool layer, because that no longer provides the marginal value. Even if you create something that's really, really novel, like for the end user, the marginal value is very minimal. It's decreasing. It's more meaningful to innovate at the API layer. Like how do you fetch data, for example? How do you do server-side rendering more smoothly? How do you unify front end and back end? Right? That's where these meta frameworks are trying to do. And they realize, okay, if we want to compete on these usage patterns, then I don't want to waste time on figuring out how to configure Webpack again. I want to have something that's more higher level abstraction than Webpack that solve the build tool problem for me, right? So that I can focus on innovation that actually matters to my users. So what we want to do is give this common foundation so the innovation can happen at a higher level of abstraction that benefits more users in different ways. At least that's my reasoning for doing this. Yeah.
And did you say that people, coagulated around Vite? Was it something in the right time, right place in the ecosystem where Vite started to gain ground? Is it some way that Vite in the internal APIs is flexible enough to seem palpable for people wanting to plug in?
I think it's a mix of both. Like Vite definitely arrived at the right time when people were starting to get tired of Webpack, and we were the first one to leverage native performance of ES Build. and unbundled ESM. That kind of gave us a head start where we showed people like, hey, first of all, you can have way better DX, way faster server startup time, way faster HMR. Then we actually, I think one thing we nailed is a good balance between work out of the box for SPA use cases, but also have a flexible enough core to support frameworks. So the core build logic and the dev server is in the same package. So frameworks we essentially provided patents to frameworks to say, hey, this is how you can leverage Vite to build your own framework. And then we have first class concepts of how you can run your same code, not only in the browser, but also in Node.js or SSR, which is a headache for people to set up when they were building on top of Webpack. Like, it's not that Webpack is not capable of doing that. It's just the abstractions that Webpack provided and the hoops you need to jump through to set up something properly is a lot. And also, there's no agreed on convention on what is the proper way to do it. Vite essentially provided an API, say, if you want to do SSR in Vite, this is the API you should use. So everyone's like, okay, that makes things a lot easier. And we also closely work with a lot of these framework authors as they are building the framework. We have a very tight feedback loop. So we create a Discord server. We have this ecosystem channel where all these framework authors will be put on in the same channel, and they would talk to each other. They would talk to us, and we would come up say, okay, like, we need to have this in Vite, or no, this is not the thing we want in Vite because every framework wants to do it differently, right? So that process helped us figure out what is the right line of abstraction Vite should stop at, and what are the things we should put into our scope so that these frameworks can stop reinventing the wheels.
I'm sure everybody listening is interested in the history, sort of like Evan, you're mentioning decisions made on putting some things versus not some things. You're mentioning the history of why Vite was in the right time in the right place and the different temperature it gave to people writing their build chains. Something that could help highlight the story of Vite and how you and the team arrived here would be digging a bit into that thing you just mentioned of, hey, this is not going to make it in. It doesn't play with the framework, right? Can you give us an example of what one of those technologies were that didn't make the cut and some of the reasoning and thinking behind that?
I guess we debated a lot on whether we want to open up the CLI Vite so that people can inject their own commands and use Vite as the CLI for their framework. I guess that is actually still a thing that we come back to from time to time, because we're seeing some frameworks are not being shipped as framework as a Vite plugin. For example, a Remix, aka React Router, and TenStack are now being shipped as Vite plugins. And in a way, Vite becomes the CLI people interact with instead of a framework-specific CLI. But I guess in the beginning, we felt this kind of confuses people between the line between what is part of Vite and what is part of the framework. And the most important thing we did eventually put into Vite is definitely the SSR, like, how do you run modules for SSR API? Because I think before we had it, I was trying to put together a demo showing people how you can use Vite to do SSR with Vue, right? So as I was working on it, we also saw that the SvelteKit team was working to add SSR. And at that time, they were still using Snowpack. And Rich Harris came up with this API called, I don't remember what it was called in SvelteKit back then, but it was a transform that takes some ESM code and transform it in a way so that it can be wrapped around and instantiated as a fixed CJS module in some way. We could essentially take the ESM, instantiate it, and build a whole, then we walk its imports. We also instantiate its imports. Essentially, we built this whole graph of virtual modules in Node.js. But we also run these module source code through Vite's own transform pipeline. So we applied TS transform, applied, for example, Vue or Svelte component transforms that you would typically do. So you can essentially have these running in Node.js, but you also have kind of pod module replacement, because when you edit, we can partially update the module graph. So you can rerun the server request and you will get updated modules. So that was the thing that essentially abstracted away the complexity of doing SSR. And we found that, okay, this is actually framework agnostic, right? Because as long as Yeah, as long as it runs the whole Vite transform pipeline, which means you can put a Vue plugin in there and it will work for Vue. You put the spell plugin in there, it will work for spell. So if a framework can work with Vite through a plugin, then this abstraction can work for all of them. We ended up just putting this inside Vite itself and called it the SSR load module API. And the transform itself actually now is also used in VTest. That's how VTest runs your tests, in fact.
Interesting. Never knew
Yeah.
that.
So
Wrapping them.
VTest had this thing called Vite Node. It was inspired by the SSR modules API, and we're actually unifying them to some extent. The use case is different, but I think it was Anthony Fu that came up with Vite Node. Correct me if I'm wrong. Was it Vladimir or Anthony who came up with Vite Node first? And I remember he told me, like, when I came up with Vite Node, I had no idea what it could be used for. And then I saw you guys want to have a test runner for Vite. It turns out Vite Node was like perfect as the foundation for VTest. So that's how VTest kind of just came into existence. Yeah.
That's so fun. That's like that's a penicillin moment. That's like Vite's penicillin moment of making something by accident, and now everybody uses it.
Yeah.
That's cool. Okay, so the example of what you didn't put in was interesting, and then this is an interesting example of maybe something that was questionable that ended up into a whole new API. It also makes sense why you guys would debate a little bit, because the abstraction layer you communicate to the users does command the whole image of your tool and the ecosystem built around that tool. Do you feel like the team is pretty aligned on this right now in terms of the dev plan coming up? Is there fraying into either side of the center point you guys have?
I think we've arrived at something that's been pretty solid. I think the scope of Vite hasn't really changed too much in the past 2 years or so. Like the last big thing that landed in Vite was environment API. And environment API is a new concept, but it builds on top of the same SSR load module thing. It's actually renamed now to just module runner, because you would use the module runner not just for SSR purposes, or how do you say it? For the original SSR load module, it was designed for you to essentially load your source code and run it in Node.js. But you, in some apps today, you want to run it in a Cloudflare worker. If you are developing against a Cloudflare worker, you don't really want your local development code to be running in Node.js, because there would be inconsistency when you deploy production, right?
You have to use this whole mini flare.
Yeah,
mini thing. It was a whole thing.
Yeah, but so we realized actually for a lot of frameworks today, there will be new runtimes, because you can have WinterCG compatible runtimes that's not Node.js essentially, right? And there will be some Dino and all being for Node.js compatibility, but there could be subtle differences. And some users would prefer to stick to a sort of like web standards only runtime, so it can run anywhere. But the point is, your code can run in the browser, it can run in Node.js, or it could be running in workers or other sort of like edge environments. If you are developing it, you want your local code to also be running in those environments. And sometimes they would want to run in these environments in parallel, because you would have your browser and then you have the worker that's doing the SSR, and you want to debug it at the same time. Right? So we want to unify the concept between these. So with environment API, you're thinking of browser as an environment, you're thinking of worker as an environment, you're thinking of Node.js as an environment. They all have their own module runners. In the browser, the module runner is the native VSM. We leverage the native VSM to be browser's module runner. But in other environments, you would want to actually use our version of module runner so that you get the same transform pipeline as all your browser code. You also get HMR. I think I got slightly disconnected. But the purpose of environment API is to abstract away all the things Vite would need to do to your source modules and give you a consistent interface no matter which environment you intend for them to run. And this was the thing that, again, we were trying to look at what these frameworks are trying to do and what are the abstractions that will be shared across them. So Vite would essentially go as high as we can at the abstraction levels and stop right where we think, okay, if we do more of this, it would only work for this framework, but not for the others.
Got it. Okay.
Yeah.
that like pinnacle moment of being over prescriptive, do you see a scaling issue or maintenance issue with the runtime maintenance for which environment API you choose to plug in? Cloudflare is huge. I don't want to
Yeah.
act like it's a random thing, but it's something else that requires maintenance yet still.
Yes, actually, environment API doesn't really require us to do a lot of like runtime specific support. We essentially only give you the abstraction to turn your code into something that can run in any standard, any JavaScript compatible environment. So it is obviously your responsibility to only use certain things that would work in
Got
your
it.
target
Okay.
environment. There is actually part of the work that's interesting because there is something we are now seeing that is a common need also across frameworks, but that's currently not handled by Vite. It's handled by something called Nitro. Not many people probably know what Nitro is. It's actually a hard concept to explain. But imagine, let's say, you have a framework like Nitro is the underlying server part that's used in Nuxt. So Nuxt builds on top of Vite and Nitro. As a server-side rendering framework, right, you want to be able to deploy on as many platforms as possible. For example, Nuxt can be deployed on Vercel. You can deploy on Node.js VPS, or you can deploy on Cloudflare, which means your code will probably need to be able to run in different runtimes. So Vite, because it only handles the front end and development, we don't concern ourselves on how you eventually deploy your code. But Nitro is the part that actually takes your server-side code and convert them into essentially plug them in with some adapters so your final bundle can run in your target environment. So you would have write the same code and Nitro would be able to essentially convert it into something that can run on Cloudflare or on Vercel or something more specific platforms. Think of it as its scope is not just the adapters, but the most valuable part of it is probably this sort of adapter that allows you to deploy the same code to multiple different platforms. But we're seeing TenStack actually trying to build on top of Nitro plus Vite too, which a lot of people are quite excited about TenStack Start. And TenStack Start is essentially going to follow this framework as a Vite plugin plus Nitro for the server side. And I think Astral and SvelteKit both have their own collection of adapters, but I guess because that's the part that we never handled in the past. But I think
Yep.
we're trying to see if it's possible so that Nitro can be this foundation for these frameworks to say, okay, if we all use it, then we all share the same collection of adapters and we keep maintaining them together so we can all deploy to these multiple platforms.
Potential future
Yeah.
collaboration with the Nitro stuff.
Yeah.
And that was going to be my next area of stuff to ask about, Evan, which was first, I was going to ask about Vite Plus and what the deal is with that. I've never heard of Vite Plus before, so I would love to learn if that's a thing.
Yeah.
And
This
then
is
also just like
something-
the future plans for
Mhm.
Vite, and this is one of them. So yeah, floor is yours. I'd love to hear about the next steps coming up.
Yeah, so Vite Plus is essentially a VoidZero thing. It is pretty much the unified toolchain that I was talking about in the beginning. But we were thinking, because everything we build at VoidZero is centered around Vite, it's our biggest leverage, and it's also where it ties back to we thought about, okay, let's build a unified toolchain. It's a hard thing to do, right? You can't do this without something already. You need this initial sort of traction or wedge or leverage for you to be able to pull off something like this. I think one of the reason Rome didn't get to where it should be was because they just threw away Babel and restart something completely new. So we're trying to learn from that and say, okay, if we were to build something, a unified toolchain, it has to tie into the most hopeful thing that shows the strongest consensus in the ecosystem right now, which is Vite. So Vite Plus this is still early, right? It's not something that we are going to be shipping soon, but the vision here is imagine Vite right now Vite is just a build tool. It's dev build. And also we don't really want to change Vite's scope in itself, which is why Vite and Vite Plus is going to be essentially separate entities. So Vite Plus is going to be this sort of drop-in upgrade that you opt into. So if you're still using the same Vite package, especially if a framework is using Vite as a dependency, right, the scope of Vite will not change. That is important. We don't want to make people feel I'm suddenly depending on something that's a much larger thing than I was originally intended for. But Vite Plus is going to be a superset of Vite, So you can use your path manager to alias Vite to Vite plus. It works exactly the same way. The dev and build command, the preview command works the same way. But now, if you opt into Vite plus, it can also do Vite linked. It can also do Vite format. It can also do Vite test. And it will also be monorepo aware. So all these commands, when you put it inside monorepo, it would try to infer as much as possible because it knows you're always running Vite, right? So all these commands can also be aware of each other. And that gives us the opportunity to essentially have one entry point and cover all these cases. So Vite Plus makes Vite similar to what Cargo is for Rust, where when you're thinking about organizing a Rust project, you just use Cargo for all these things. Whereas if you're having a large JavaScript or TypeScript project, you can use Vite Plus to do all these things. And that would be one single tool, one single unified toolchain to serve these needs. But at the same time, it can still support the frameworks on top of it, right? Because these frameworks are built on top of Vite, they will naturally be compatible with all these Vite Plus features. Obviously, there's a lot to figure out how to make that smooth. For example, if you're using Nuxt with Vite Plus in the future, Nuxt can potentially provide, Vite linked plugin integrations as well. So when you use Nuxt and you opt into V Plus, then Vite linked would just come with all these Nuxt specific rules bundled already. And when you run test, it could also allow the framework to tap into the test runner and inject its custom assertions or inject its own test utilities and all that.
Got it. And so if people are able to use Vite Plus, it's going almost one layer lower, you could argue, on like what it's unifying for your tool chain when you're developing a TypeScript project.
Yeah. In an
Okay.
ideal world, imagine whether you're building a React SPA or you move to a React based, for example, you're building a React SPA and then another project is React router based or Remix based, and the other project is TenStack based, or the other project is SpellKit, the other project is Nuxt. They will all be building on the same foundation. So when you opt into V Plus, all those features would work across these different frameworks.
That sounds very powerful. Have you guys been thinking about any like AI related stuff because you're unifying like the workflow and path of traversal for navigating a set of commands?
In a way, yes. I guess when you think about project scaffolding and code generation, because a lot of people like, for example, with Angular, you can scaffold a new Angular project and then you can say ng new, or Laravel has a very featureful scaffolding. I guess these full featured opinionated frameworks can essentially come up with a lot of things to help you quickly scaffold new code. In a way, I feel there's opportunity to do something in that. But at the same time, I'm really cautious about it's almost becoming a hype to latch onto AI anywhere you can. And just the other day, I was checking out some new terminal apps and I was trying Warp again. And it just feels weird for your dev tool to be constantly upselling you to sign up so you can get more CI tokens, AI tokens. It just makes me wonder, like, where do we really want the AI to live? For example, for me, I think AI integrating at the IDE level feels a lot more natural compared to something that you use from the command line. It just feels weird to have all these AI features in my terminal compared to my IDE. So I'm also thinking you probably don't want to get too much in the face of people about AI if we are just this like lower level tool chain to support people. So we're really cautious about that.
Evan, we're running up on time, so we're gonna do our quick round at the end. Okay.
Let's go.
So first question. In the push for instant dev servers and faster builds, are we sacrificing other important aspects like debugging, maintainability, or developer onboarding? Like, is that pendulum switching in the wrong direction now?
I don't think so. I think fundamentally our goal is to build things fast. And if we can collapse the complexity in a way, we want our tools to just work, right? Debugging tools is not fun. It should not be part of our job, ideally. We want our tools to be as fast and smooth as possible so we can actually focus on part of that values that creates value for our users.
Okay, question 2. If you could snap your fingers and fix one major problem in JavaScript tooling overnight, probably of the basket of stuff you guys have been working on or plan to work on, what would it be?
If it go back like 1 year, I would say, could you someone please convert all the CJS code to ESM overnight? That would make things so much easier.
It's funny. I just did a pod last week on the switching over to ESM and like why now might be a better time than ever, honestly, because of now we have full symmetric compatibility.
Yeah.
So maybe your wish will come true, Evan, sooner than you think. I'm just kidding. It'll never come true. It's like a cancer that'll always live on.
Yeah.
All right. Question 3. Will JavaScript be the dominant web language in 10 years? I guess it kind of is now. Do you think it's going to change?
I don't think that's going to change. TypeScript is still really strong. Also, with the TS-Go rewrite, I think it actually addresses one of the major bottleneck or pain points for it as a language, and the ease of being able to develop something directly in your browser and also deploy it in the browser as a delivery mechanism that's just unparalleled. And JavaScript being native to the browser is just such a large advantage. I just don't really see how, even if it's compiled to JavaScript language or a compiled to WebAssembly language, I just don't feel like there's any remote chance. I don't see any language in there that would potentially be able to challenge that. But I do want to mention a project called Vite. So if you haven't heard of it, I would recommend checking it out. It's a pretty cool language, functional, builds on lots of years of Camel compiler knowledge, and has very nice compiled to Java semantics. For example, it automatically optimizes your functional looping code into JavaScript imperative loops for the best possible performance. It's a really cool language. I would recommend people check it out. It's still very early, but I think in 10 years, Moonbit might be something to watch out for.
Interesting. I've never heard of that myself, so got something to chew on tonight.
It has some roots from the Rescript and Reason ML from Facebook, because it was created by the same guy who worked on it.
What was the name one more time, Evan?
Moonbit.
Moonbit. Okay.
Yeah.
Got it. Now, just to close things out, if people wanted to keep up to date with you, Evan, where are your most popular socials that you'd recommend people search
I'm on both Twitter/X and Blue Sky. I still struggle with cross-posting, but I try to be active on both places. Probably is still a bit more active on X.
And what was your handle? We can always link it in the show notes as well.
Yeah, my handle is the spelling of my Chinese name, Youxi, Youyuxi.
Awesome. Thanks so much for spelling that out. I appreciate it. Usually when people say their Twitter handles, I always just spell it out anyways, but you did it for me. Made it easy. Evan, thanks again for coming on. It's interesting to get it's a look behind the curtains of what's happening and things that we're using every single day. They're changing rapidly and you're at the forefront of it. So it's great to get like the opinions and futures from your own perspective. Hopefully we can have you again in the near future in like a couple months to see how V Plus is going.
Yep. Would love to.
Yeah, just thanks so much for your time, and hopefully some people can get instilled to honestly just get a little bit more interest in this stuff rather than just treating it as a tool. Go check out Vite if you have.
I would love to have more contributors, but a lot of our stuff is now written in Rust, so that there's a higher barrier for sure, but we're still getting some high quality contributors, which is really cool.
It's a barrier and a filter at the same time.
Sure.
All right. Thanks so much, Evan.
Yeah. Thank you. It was a pleasure.